Hello and welcome to lesson 4.2. In this lesson, we're going to dive a lot deeper into logarithms. So if you remember in the last lesson in 4.1, we introduced exponentials, did the properties of exponents, like anything to the 0 power equals 1 and anything to the first power is itself. If you're multiplying, we add the exponents, and if you're dividing, we subtract the exponents, all those good stuffs. And we also introduced logarithms and did some basic graphing with them, but didn't do much beyond that. So in this lesson, we're going to dive deeper into logarithms and do the properties of logarithms and start solving some logarithmic equations. So to start this lesson out, we're going to talk about a couple definitions. First one is the common log. And basically this is saying if there is no base written under the log, no base there, we assume it's a base 10. Kind of like if you have a root that doesn't have a number next to it, you assume it's a square root. So that's the same thing with logarithms. If there's nothing there, assume that it's a 10. And you should be able to notice on your button, or on your calculator, you have a log button that doesn't have a base on it. So that button will be a log base 10 button. The next one I want you to know about is the natural log. And this is log base e. Now, e is a number kind of like pi. You know how pi is 3.14 forever and ever and ever and ever. E is the same thing, but it's 2.71. And then it goes on forever and ever and ever. Basically, mathematicians and scientists noticed that this 2.7 number kept coming up in calculations all the time. So they were like, hey, since this number goes on forever, let's just give it a name instead of writing it over and over and over and over. So they called it e. But anytime you see an e, just know it's not a variable, it's actually a number, kind of like pi is. So anytime we have log base e, we notice that log base e kept coming up a lot. So since it came up so much, we gave it a shortcut name, a shorthand. So we call that ln. So basically, anytime you see ln, just know that that's the same thing as log base e. They're totally identical, it's just two different ways to write it. So, now that we know about the common log and the natural log, let's do example 1. In this first example, we have a story problem. The state of Utah has one of the fastest growing populations in the country, with an annual growth rate of about 2%. The number of years it takes for a population with the growth rate of R to double in size is this equation. And you'll notice that these logs do not have bases, so we assume they're base 10. So it says, at the current rate, how many years will it take for the population of Utah to double in size? So at the current rate, so that means at the current rate of 2%. So I'm going to put 2% in for my rate. I'm going to change 2% into a decimal. And then I can just plug this into my calculator, and that will give me how many years it will take for the population to double in size if it has a growth rate of 2%. So I type that into my calculator and find that it gives me 35.00 years. At a growth rate of 2%, it would take 35 years for the population to double. Then it says, what if the growth rate is reduced to 1.5%? So now let's put in 1.5, turn it into a decimal. Yeah, there you go. And then plug it in to see how many years it would take for the population to double in size if it has a growth rate of 1.5%. So before we type this in, just thinking about it, if the growth rate slows down, do you think the years it will take to double will increase or decrease? Well, those years will probably increase. If we're growing slower, it's going to take longer to double in size. So we type all that into our calculator, and lo and behold, 46.55 years, which is longer. So if our growth rate is only 1.5%, it takes a little longer to double the population. So that is an example of a logarithmic story problem, and we've defined the common log and the natural log. In the next video, we'll go over the properties of logarithms.